Unit 1, Alchemy, had 5 different chapters in it. And I'm going to give you the overview of the unit just to review some of the themes that we looked at, and then I'll go through each of the chapters in review. Hundreds of years ago, alchemists were trying to turn ordinary substances into gold. The overarching question for this unit, is it possible to create gold from other substances, was accompanied by 2 other important questions. If so, how is it done? And if not, why not? In this unit of investigation, you were introduced to what matter is and how density can be used to determine if matter had changed into a different substance. You also were introduced to the periodic table of elements. Next, you considered the merits of historic models of the atom before arriving at a basic model of an atom. You studied nuclear reactions, moving electrons, naming compounds, and the 4 different types of bonding that exist for different substances. Throughout the unit, you returned to the central question, is it possible to create gold from another substance? The ultimate answer to that question is both yes and no. The gold found here on Earth was created somewhere in the stars through nuclear processes. However, that option is not available to us in the laboratory. So, while it is theoretically possible through nuclear chemistry, making gold from another element or other elements is not feasible here on Earth. Chapter 1 was called Defining Matter. And in Chapter 1, we started out the chapter by looking at the gold penny demo, where we came up to the front of the room and we took a copper penny, we placed it in a beaker that had some sodium hydroxide and some zinc metal, and we first saw that the penny turned a silver color, and then we took the penny out and we heated it in the Bunsen burner or on the hot plate itself, and we saw that the penny slowly turned into this golden color. And that was the demo that sort of fueled the entire chapter and rest of the unit. Was it possible to actually take that copper penny and turn it into gold? We started off our investigation in that chapter by looking at lab safety and lab equipment. So you should be familiar with all of the lab equipment here. You have a table in your note packet that had lab equipment and the basic lab safety rules that we've been using this entire year. We looked at the definition of chemistry, which is the study of matter, the changes matter undergoes, and the energy involved in those changes. And if you think about the entire year, we started out looking at matter. We slowly looked at the changes that matter undergoes, both physical changes and chemical changes. And then the last bit of the year is going to be focused on the energy that accompanies those changes. So the entire year really broke apart that definition of chemistry. In the study of chemistry, we use observations, inferences, and hypotheses to study chemistry. You should be familiar with those terms and the differences. Remember, observations are things that we can say with our 5 senses. So maybe the texture of something, what something smells like, what I'm seeing in a reaction. An inference is sort of a guess based on prior knowledge, what we think is going on, what we think caused something to happen. And then a hypothesis is taking an inference and phrasing it in a very specific way, that if-then format, so that we can use it to study during an experiment. We then looked at the definition of matter as anything that has mass and takes up space, and taking up space means that it has volume. We can describe matter based on its composition, which is the components of matter. So for example, water is composed of hydrogen and oxygen in a ratio of 2 to 1. Or we can describe matter based on the properties it has, some distinguishing attribute or quality, like color or texture. We looked at examples of things that are not matter, things like light, or energy, or thoughts, or feelings. Things that are not tangible are not matter. We broke apart the definition of matter and defined mass and volume, mass being the amount of matter that's packed into a substance, which has units of grams and kilograms. Most often that's what we use throughout this course. There are other units for mass. And volume is the amount of space that matter occupies. We use these common units for volume: liters, milliliters, and centimeters cubed. We finished off this chapter by taking mass and volume, and looking at how we can use both of those to calculate the density of an object, which is the mass of something divided by its volume, and use that as sort of a characteristic property, that each substance has its own density, and we can use density to identify what an object is. You would have to find the mass of an object, most commonly using the balance, the electronic scale. And then volume, if it's a regular object, we can just do length times width times height using a ruler, or we also looked at if it's irregular and we can't use a ruler to measure the volume, we can use a process known as water displacement, where we have some amount of water in a graduated cylinder. We place the object into the graduated cylinder. Because that object takes up space, it's going to take up some of the space in the water. It's going to increase the level of water to a new level, and what I can do is look at the difference in the level of water, and that would be the volume that my object is taking up. And then I can use that mass and volume to find the density. We can then use the density to identify whether or not something is in fact copper or gold, as we did with the penny. And the last thing you should be familiar with are the relationships between density and objects. If, like, for example, here, if you have two objects of equal mass, meaning the number of particles in each are the same, but the volumes are different, the one that is occupying more space has the lower density because the mass is more dispersed, and the object with the smaller volume has the higher density because the matter is more compact. If you have two objects with the same volume, as indicated by the same size square here, the one that has more mass, meaning more particles, is going to be at a higher density, but the one that has less particles or less mass is going to be the lower density. That summarized Chapter 1. You should go back through the note packet for Chapter 1 and look at the lesson objectives. Make sure you're clear about that. Look at some of the practice problems we worked on. But that takes us to the end of Chapter 1.